Okay, welcome back everyone. In this video we're going to be discussing the difference between temperature, heat, and kinetic energy. And I do not want to update my software. Okay, so temperature, just to start out with a definition. When we talk about temperature, this is basically a measure of the average translational kinetic energy of molecules. And when we say this, molecules actually have three different types of energy that they possess. So if you think about one atom, let's just say maybe oxygen, and another oxygen atom right here, so we're talking about the O2 molecule, I can model that as two atoms being connected by a spring. And we know that this spring right here is actually the electrical bond. I think with oxygen we're talking about a covalent bond, right? You'll have to let me know if I'm wrong. But with a covalent bond, so they're sharing the electrons, and this kind of ties them together somewhat loosely. And so the three types of energies stored in a bond like this, or in a molecule, well, first of all, the bond itself can be a little bit shorter, a little bit longer in length, and basically the two oxygen atoms are vibrating back and forth. And in real life this happens in 3 dimensions, but we're only talking about this in 1 dimension right now. So we could talk about the so-called vibrational energy. Well, along with that, the entire molecule itself could be rotating. And there's lots of different ways that that can happen. So we could have rotational kinetic energy. But the thing that we are mostly concerned with is ignoring those two effects and just thinking about that molecule's overall speed through space. And that's what we call the translational energy. And that translational kinetic energy could be written roughly as 1/2 mv squared, where this v is kind of an average value of the velocity. Because in a gas, we typically have billions and billions, well, we have moles of particles, so we're talking about factors of 10 to the 23rd particles, right? Or molecules. So when we talk about the translational kinetic energy, we really do mean that it is an average of all of the different kinetic energy of the molecules. And getting into the details of this is a bit beyond what we want to do in this video, but at the very least try to keep in mind that if you look at a spread of kinetic energy versus the number of molecules, you're going to see some sort of a curve. So there's going to be a peak, and that peak is going to kind of tell us what the temperature is if we read off the kinetic energy. Okay, so that does a good job of discussing temperature. Now we'll go to heat. Okay, and heat is actually fairly simple. It's just the energy transferred from one object to another because of a temperature difference. So heat won't flow unless there's a temperature difference between two things. So for example, if I have two different sides of a chamber and I have T1 and T2, if T1 is equal to T2, then there's going to be no net flow of particles back and forth. But if T1 is greater than T2, then what you're going to have is, because those particles on the whole have a greater kinetic energy they're going to end up moving to the location where it's a lower temperature. And back in the day, they used to think that the flow of heat happened because of an actual fluid-like substance called caloric. So this was a fluid-like substance that we thought, well, this is probably 200 years ago. And it was thought to sort of control the flow of heat. Or energy. And as it turns out, caloric doesn't exist. So the idea of the calorie, however, as a way to kind of measure heat, sorry, not the calamari, the calorie is kind of a way to measure heat, or rather energy. And there's something that we call the mechanical equivalent of heat. And that basically says that 1 calorie is about 4.19 joules. Okay, and I should be careful, that's a little calorie like that, because there's also a so-called calorie with a capital C that's 1,000 calories with a little c. Sometimes it's called a kilocalorie. So when you look in your food and it says, oh, that this has 500 calories, you're talking about kilocalories. Okay, so we've talked about temperature, we've talked about heat a little bit, and these three things that we discussed earlier, the vibrational, the rotational, and the translational kinetic energies, these are all lumped together into what we call internal energy. And so the internal energy of a gas has to do with these three different types. And finally, one quick analogy to let you think about heat and temperature in a different way. So, for example, if you have a sparkler at the 4th of July and you have one little spark that falls on your arm, it's not going to do a lot of damage because the sparkler has a very high temperature. Right? It's got a high temperature, but that one spark by itself carries a low amount of energy. So very little heat is transferred. On the other hand, if you have a bonfire, you might not know this, but compared to a sparkler, we're talking about a relatively low temperature. The difference is we're talking about a high amount of energy that's transferred if you happen to jump in it. So the moral of the story is don't jump in a bonfire. Okay, and we'll see you next time when we talk about temperature scales.